In the question 18, we have x, y, and number, so we should apply the rule. If I take y other side, 2x minus y minus 1 is equal to 0. I should write my equation in general form. The coefficient of x is a, which is 2. The coefficient of y is b, which is negative 1. The constant is c, which is negative 1. The rule itself is the absolute value of a times x1 by1 plus c over square root of a square plus b square. And x1 and y1 are the coordinates of the given point. If we write everything in its place, a times x coordinate of the point, b times y coordinate of the point, the constant over square of a is 4, square of b is 1, under root. Numerator is going to be 2 minus 3 minus 1 and minus 1 minus 2. Denominator is root of 5. The absolute value of minus 2 is 2 over root of 5. 2 over root of 5 is the distance between point and line. Question 19 is again finding distance between point and line. Line is special, which is vertical. We can use the shorter way. I mean, we can apply this way for a multiple choice question. Distance will be difference of, since the given equation is x and x coordinate of your point, it will be the absolute value of negative 7, which is going to be 7. Answer is B. Question 20, 2 points are given. Our question is what should be the third point to be collinear. Collinear points are points on the same line, so the slopes 2 by 2 will be the same. Let me call my points as A and B, and let me find the slope of line given from the points. Delta y over delta x, so change in y over change in x, which is going to be 1. I am looking for one more point. It is also going to give me 1 as a slope by using one of the given point A or B. Or we can use the logic also. Since the slope, before this step, if I pay attention here, change in y over change in x, you can add 1 to x coordinate of given point and plus 1 y coordinate of your given point. One of my point is 1 and 0. Pay attention. If I add 1, it becomes 2. If I add 1, the question becomes 1. 2, 1 is another point. So if I use same logic, the third point can be 3, 2, 4, 3. But there is no choice like this. So if I go back, subtract 1 from both, negative 1, 0. If I subtract 1, 0 and negative 1 is going to be the point that we look for. Answer will be C. Or one by one, you may try each point, and a given point you may try to find the slope. You should get 1 in the end. Question 21, it is similar to question 16. There is a point like xy, maybe easier than the previous one, and we are talking about origin 0, 0 and the point 0, 3. Okay, and What is the relation between the distances? Distances are equal. I am going to use the logic of question 16. First of all, I have to find the distance one by one. D1 is going to be the distance between origin and the point x1, and distance from xy to 0, 3 I can call like D2. D1 is x minus 0 square plus y minus 0 square. So D1 is going to be square root of x square plus y square. If I find the other distance, D2, difference of x coordinates with square, difference of y coordinates with square, y minus 3 square with square root. So it becomes x square plus y minus 3 square. The relation between two distances, they are equal to each other, so D1 is equal to D2. D1 is equal to D2. X to the power of 2 plus y to the power of 2 with square root should be equal to distance 2, which is here. I can also expand the parentheses. X square plus y square minus 6y plus 9 with square root. Taking squares of both sides will help us to eliminate the square root. If I take square of both sides, the equation is going to be x to the power of 2 plus y to the power of 2 is equal to x to the power of 2 plus y to the power of 2 minus 6y plus 9. This equation is easier than the previous question since we have the same terms with the same quotient. So let's cancel x squared y squared from each side. So x squared will be cancelled, y squared and y squared will be cancelled. There is 0 here. There will be minus 6y plus 9. Let's have a look for the questions. 9 minus 6y is equal to 0. 9 minus 6y is equal to 0. Answer is going to be B. Question 23, 22, 23 about finding unknown if points are collinear. Collinear points will have the same slopes. If I take point 1 and 2 and 1 and 3, and if I equalize their slopes, the first slope, I mean by using first and second point, difference of y coordinates t minus 1 over 0 minus 1, it is t minus 1 over minus 1. The second slope is going to be the slope by using first point and the third point. Difference of y coordinates 5 minus 1 over difference of x coordinates minus 2 minus 1. Numerator is 4, denominator is minus 3. Since collinear points are the points their slopes should be same, t minus 1 over minus 1 should be equal to 4 over minus 3. If we do cross product, negative 3t plus 3 is negative 4. Negative 3t is equal to -7. If I use -3 to divide, t is going to be minus and minus plus 7/3. To be collinear, the value of t should be 7/3. Answer is A. Question 23 has the same logic. I can make a difference. If you want, you may also use name for your points. I don't want to repeat unknown twice, so I will use A and B and C, and their slope should be same to be collinear. The slope of line passing through AB is going to be difference of y coordinates 1 minus minus 1 over difference of y coordinates, x coordinates, sorry. So it is 4/m. The slope of line passing through BC. The slope of line passing through BC. Difference of y coordinates -3 minus 0 over 0 minus 2. It is -3 over -2. You may cancel the minus sign. 3/2. To be collinear, the slopes should be same. Slopes should be equal. 4/m must be equal to 3/2. Cross product is going to give us 3m is equal to 8. So m is going to be 8/3. Answer is B. Question 24. Y-intercept of the given line. Y-intercept is common point of line and y-axis. It is here, which is 0, -1. Which one of the following is not x-intercept? X-intercept is the case of writing 0 for y. If I write 0 for f of x, x plus 1 cube x squared minus 1. I can do factoring like this to apply factoring by grouping. X plus 1 cube can be written x plus 1 squared times x plus 1, and x squared minus 1 is the special identity. I can write x plus 1, x minus 1. I have to solve this equation, but I cannot solve without having product between expressions. I am going to take x plus 1 as a common factor. So 0 is equal to x plus 1 is common. Let me write the remaining x plus 1 square plus the other remaining expression is x minus 1. X plus 1 times, expand the power, x to the power of 2 plus 2x plus 1 plus x minus 1. Plus 1 minus 1 can be cancelled. The last step is going to be x plus 1 x squared plus 3x. If I use zero product property, I am going to see there are three solutions. One of them is -1. So -1 is one of the y-intercept, but our question is about not an x-intercept, sorry. And if I take x as a common factor, there will be two solutions. One of them is 0, the other one is -3. So they are the x-intercept. -1, 0, -3 are the x-intercept. Not x-intercept is the case of x is equal to 1.